In this video, I want to say a little bit about ecosystem restoration benefits because it's been a recurring idea in some of our discussions. Let me try to make this complicated model brief. This is Tenkiller Dam. It's a core dam. It's in Oklahoma, and it is a dam that is upstream of a river where trout, bass, and catfish fishing are popular. The water that's released from the dam is very cold and it has very little oxygen in it. And so a continuing authority project was going to build a little weir dam that was going to oxygenate the water and improve fishing habitat. So many years ago, we did a little evaluation to show that risk assessment was possible. This is going to look quite complicated, but it's basically a habitat suitability index model. So this is a HEP procedure. What we have here are different habitat variables, in this case for bass. What we have in the columns, this is without project condition measure of the particular habitat variable. So for example, the percent of pool cover was 82%. These input values in column B are translated into suitability index values, a number between 0 and 1, where 0 is bad and 1 is good. And then there is some arithmetic. You take all these different variables here and you combine them in ways that produce estimates of life requisites like food and cover and water quality and so on. And ultimately what you end up with is a habitat suitability index. So we take the habitat suitability index, 0.1 times the number of acres, and we get habitat units, 1.853. So this is the without condition in column B. This is the with condition in column C, and this is the difference in column D. Now we do this for a number of different reaches called sites here. So site 1, 2, 3, and 4 are just different reaches. So all of this gets aggregated down here into the total. So this is habitat units in all 4 sites would be 5 under the without project condition. With the project there would be 28.8 and the change would be 23.769. Now what we're talking about is uncertainty and transparency and whatnot. So what I would like you to know is that we don't know what this value is, what the pool cover is. It could be that, or it could be 63%, or it could be 84 or 76, and so on. And so you see a lot of these values changing. And they're changing because instead of representing them as a number, we represent them as a probability distribution. But down here is what I would like you to see. We don't know what the change in habitat units is going to be. And so it could be only 5, an improvement of 5, or 25, or 15, or 17. And so it goes. We did the same thing for catfish. Let me go up to the home, and we did the same thing for trout. And once again, let me go home for those. So you can see that we're saying we don't know exactly what those values are. So here I've accumulated all the habitat units. You can look at the habitat units by reach. So we've got 19 there, 8, the 28 here, 23 here, and 9 in reach 4. Or you can look by species. But the total is the same for both. And so what I'm going to do is run a quick simulation, but perhaps I should jump back here and at least give you an example of, let's see, I'm looking for something that will be a simple example. Let me see if I can find something a little simpler. Okay, yeah, so let's go with percent of pools, 8.499, and what's really in there is a probability distribution. This distribution says we don't know what the percent of of pools is in this reach, it's somewhere between 50% and 100%. Do you know anything else? Well, what we knew is, what we said is, most likely it's going to be 77.5%. So we grab that number, lift that up, and then basically take our ruler and connect these 3 points. So when I hit F9, the computer is picking a number off of this part of the number line between 50 and 100. It picks numbers in this fat part more often than it does numbers in the tails here. And that's going on in all these different cells. So back to our total now, and let's see, I'm going to change this to 1,000 iterations so that we don't take too long with this little demonstration. Not exactly what I was looking for here, so let me close this and browse the results. So this is what we would say about ecosystem restoration. What are the benefits? And the answer is, I don't really know what the benefits are, because I don't know what percent pool cover we have. I don't know really what the mean high temperature is, or the dissolved oxygen, or I don't really know any of those habitat variables. Notice over here we've got some numerical summary. My smallest estimate was an improvement of 38 habitats units, could be as much as 110. Our best guess is 75.093. So when we would report numbers like this, what we would do is use a 5-number summary. We'd say it's a minimum of 38. We'll go down here to the first quartile. There's a 25% chance that it's 67 or less. Then we would go to the median. There's a 50% chance it's more than 75 and a 50% chance it's less than 75. We'll go to the third quartile here and say there's a 25% chance it's 82.9 or more. And then finally we would say, and it would be a maximum of 110. So it is indeed possible to do this sort of thing with ecosystem restoration. It's just a matter of having the culture and the desire to do so. So I hope that was kind of helpful for some of this discussion we've been having.